Okay, good morning. Yeah, welcome. So, I would like to present something this morning, and for our campaign. So, we'll be looking at some topics from the campaign: sampling ADC, generating mathematical equations, adding offsets. So, there are some problems that you encounter when you are programming. You are writing a C program, you are writing a program for a product or for a specific purpose, and you don't know what to do. You have tried everything, you have tried, so you have to try. So when you are using trial and error method, to solve a problem, we might term it as brute force. So note, we are trial and error. That's trying all possible options or combinations. You get what I mean? All possible options or combinations to get your desired results. So, in doing that, there are some things that you are meant to know, like sampling ADC. Assuming you want to take a reading from your microcontroller, and those readings that you're taking are jumping up and down. Maybe it's an AC voltage you want to take reading, and it's jumping up and it's oscillating. You can actually sample the signals. You get what I mean? You can actually sample the signal. Maybe you can take about 100 units of the signal. Then you find the word average. So by taking average, that means you add up, you read the ADC 100 times and add it up, then you divide by 100 to get the average. That is called, you're taking an average, you're trying to sample and get an average reading. Or possibly we can take the highest reading and the lowest reading add the two together, add and divide by 2. So I don't know, in program you must have seen max point, you see mean point, there you see ADC reading, underscore reading. So you have a function like, if open bracket, I'm writing a C program, if open bracket ADC reading is greater than max point, understand, max point equals ADC reading. Are you getting what I did here? This is a simple line instruction. So here we said if ADC reading is greater than max point equals ADC reading. So what we are doing is that once we take ADC reading, we check if it is greater than max point, then the max point is equal to ADC. Then let's do for the minimum point. So if ADC reading is less than mean point equals what? ADC reading. Are you getting? So now you've gotten the highest number from the sample of ADC you are getting. I've gotten the minimum number, so you now do max point plus minimum point divided by 2, or times 0.5. So I've just showed you different ways of getting average reading. That's sampling ADC. First, you can take an average. Then you can also create variables. That's your max point as integer. You can say unsigned int max point. Then your mean point, you do the same, unsigned. You assign a variable to it. Then your ADC reading, unsigned int. Then you can perform this simple logic. If ADC reading is greater than max point was ADC reading. If ADC reading is less than is less than minimum point, mean point equals ADC reading. Max point plus mean point divided by 0.5. So that's for sampling ADC. So with this you can get a relatively you get something close to what you want. So with the variable you get, with the value you get, you can work on the problem you're trying to solve. So we also talk about generating mathematical equations. You know that in ratio, like remember when you are in secondary school, when they talk about thermocouple, you want to get the temperature, or you want to do temperature relation. You have 0, you have 100, 2 limits. Then you have you now have reading at the other side. Maybe you have expansion. So you have to form a mathematical relation between two of them. You see? So that one we are going to solve it on paper, then we'll try it out. But I'm going to use a practical example of a problem that I encountered when I was trying to find percentage. For Arduino, you can use a function to solve it. So, but for PIC and some other microcontrollers, you need to write the function. You need to write the code yourself. So we are going to talk about that briefly. We're going to talk about that later, but I want to continue with the sampling of ADC. So ADC simply means analog to digital converter. So ADC can be modeled as two processes, sampling and quantization. Sampling converts a time-varying voltage signal into a discrete time signal and the sequential of real numbers. Quantization replaces each real number with an approximation from a finite set of discrete value. So this is how is ADC sampling done. So this is a value from the sensor, transducer, signal conditioning, analog to digital converter, the driver software, application software. So first, how do we source ADC? ADC is gotten from a sensor. Some sensors produce analog signals, while some produces analog and digital signal, just like our smoke sensor has analog and digital signal. So what the digital signal this process is found inside the analog and digital analog to digital converter. It converts the analog signal, passes it through its transducer, then the signal conditioning. or signal conditioned signal, then analog to digital converting, then quantization. So after quantization, we now get our discrete numbers. So this is the process it goes through. Peradventure that you don't have we all know how to convert analog to digital. Peradventure, you know there is what we call resolution of ADC. Some ADC values are of resolution of 10. Some microcontrollers give you resolution of 16. What do I mean by resolution of 10? That's 2 raised to power 10 minus 1. It is called, the resolution is 2 raised to power n. Let me use this symbol, 2 raised to power n minus 1. So if the resolution is 10, that's 2 raised to power 10 minus 1. That is the resolution of the ADC, which is 1023. So that is the resolution, the ADC. We also have some ADC that can give you resolution of 32. So based on the particular microcontroller you are using, you can get different resolutions for your problem or for what you want to tackle. So this course is not for people that are just starting. These are people that have already known, that have been writing programs for years. Some that are just an easier way, or some are just trying to give tips on how you can make your coding more efficient, on how to use relational use bitwise operation, and how to also use simple functions to perform arithmetic operation. So we are going to be seeing more of numbers, we're going to be seeing more of calculations. I know each and every one of us are mostly engineers. So we also have generating mathematical equations. So this particular one, I'm going to be using pen and paper. I'll write out I'll have an example, then I'll transfer it to our slideshow or to our screen so that we can see what I'm talking about. What if you have an ADC, you are given an analog signal, and you are asked to get to generate a mathematical equation to get a percentage, assuming you want to calibrate a sensor so that it shows in percentage and not ADC value. Peradventure, you want to kick off some numbers and start. Once the sensor starts, it starts from a particular number to start sensing. Any value less than that is considered as 0. So what are you going to do? That is the next one we are going to look at. That's generating mathematical equations. Adding offsets. What are offsets? Offset is just number or variable that you add to a particular equation or function to either to make it to get a reasonable value. Like you can decide to add or subtract offset. So if I add -1, that means I'm shifting it by -1. That's from my scale. An offset can be added either in any axis. You can add offset to y axis, you can add to x axis, you can add offset to your variable, to any of your variables. So what we are trying to do by adding offsets, we are trying to, instead of using variable, we want to use offset to get what we want. You get what I mean? So offset is very important in programming. So we are going to Google the meaning of offset so that you can know what I mean. It's a consideration or amount that diminishes or balances the effort of an opposite one. The amount or distance by which something is out of line. You understand? So let's check offset. Let's check offset in mathematics. A short distance measured perpendicular from a mesh survey line. That one is in building. So let's say offset in programming. Let's check programming. So in computer engineering and low-level programming such as assembly language, an offset usually denotes the number of address locations added to the base address in order to get a specific absolute address. You get, this one is in programming. So what is an offset in memory? That's an offset in memory. The offset is the second part of a logic address that permits to locate an address inside a memory segment. So look at address starts from a memory segment starting at 0. An offset is also known as an effective address. That's when we are talking about offsetting address or offsetting programming. So that's just something added, just as I said. So the remaining segment of the video will be coming up. So I hope you guys learned something from this short video that I made. Thank you very much.